Hello, students. Okay, so you probably want to pause and copy this down, but what we're learning here is how to calculate a remainder or error off of an alternating series. Okay, so in this definition, first what you have is it says if S, meaning the sum, okay, which is equal to this alternating series. So you have the sum of an alternating series. If this is the sum of a convergent alternating series, so how you know if it's convergent? This can only be applied if you know that you have these conditions that are met, which we also already learned with the alternating series test. Then the absolute value of the remainder, which can also be called the error bound between the series and the partial sum. And just as a reminder, series is the sum of an infinite number of terms of a sequence. Partial sum is the sum of the first n terms. Remember, you start at the first term and end at the nth term. So this represents the difference between the two. So if you start off first, you would have the sum of an infinite series. That would be my S. And if you were to subtract the partial sum, which is the sum of the first n terms, you would be left with the remainder, which I call like the tail end of the series. And I'll show you what I mean in a minute. So this would be equal to the remainder. If I do absolute value of this quantity, then I would have the absolute value of that remainder. This quantity in this remainder is always going to be less than or equal to the value of your next term in your alternating series of your Bn, not including the -1 because we did the absolute value. Okay, so pause if you need to copy this down and then move on. All right, so what do we mean by this? So suppose that we have this problem. It says calculate the error/remainder of the fourth partial sum of the series. And here's our series. It is the alternating harmonic series. Okay, so what would we do? Well, first I would look at what the alternating series looks like. Here it is, 1 minus 1/2 plus 1/3 minus 1/4, and so on and so forth. And we go on forever. Now I want to do the error/remainder of the fourth partial sum. So what we're going to do is we're going to find the fourth partial sum, which is S4. And that is the sum of the first 4 terms. So this is what I have, the first 4 terms. So now when I subtract the 2, what's going to happen? These guys are going to cancel from each other, and I'm going to be left with this tail end right here, which is 1/5 minus 1/6 plus 1/7, and so on and so forth. And it goes on forever. Now, this remainder, the largest value that it can be is 1/5. Now, 1/5 is already positive in this situation, but had my exponent be different, it might have been negative, and I would just take the absolute value. What is the largest value that my remainder can be? Is 1/5, because I'm taking the sum of an alternating series, so of a convergent alternating series. So if I do 1/5, I'm going to subtract 1/6, which is less than that. So I'm going to take some of it away. And then I'm going to add 1/7, which is less than 1/6. So this is going to be decreasing. This has to be the largest value, because as I take away and I add, all the values that I'm taking away and adding are always going to be less than the previous value. So that is why the largest value that this sum could be is 1/5. And so if I put it straight into my theorem there, it says the remainder, absolute value of the remainder of the fourth partial sum is this. The series minus the fourth partial sum has always got to be less than or equal to the fifth term, the absolute value of the fifth term, that is, which in this case is 1/5. And that is how you calculate that. And just remember that you can only calculate it as long, you can only use this as long as it is a convergent alternating series. The end.